Hello guys, welcome to East Coding. In this video, we are going to see the Leetcode problem number 901 online stock span. Let's get into the problem. So the problem statement is design an algorithm that collects daily price quotes for some stock and wait a second, returns the span of the stock's price for the current day. The span of the stock's price today is defined as the maximum number of consecutive days for which the stock price was less than or equal to today's price, that is starting from today and going backward. So for example, the price of stock, that's an example given in which they have given the stock prices and the spans of each day. So we need to implement the stock spanner class, in which firstly we have stock spanner constructor which initializes the object of the class. Next we will be having a function next which will return the span of the given day. So that's it. So let's get into defining the problem statement. So before moving on to approach, we need to firstly define the problem clearly. So only if we define the problem clearly, you will be able to come up with the approach in the proper way without any mistakes. So what is the input? So the input will be the days, the stock prices. So but actually this is not a input, so actually they will be calling you in the function call. They'll be having a function call for wait a second. So next, that's a function next. So input will be next, in which they'll be passing the price of current day. So output should be price, that is sorry, span of the current day, span of current day. So span will be written for every function call. So this is the problem statement. So we have to define the other statement. So if we have to find the span of each day, right? So they'll be giving a day. Let's say day one. Day one, what is the span for this day? So let's consider such days, day and span. So initially will be called using a function call which will be span. So day one, what is the span? So they'll be giving a day two, price of the day two. So p1, p2. So what does the span? What is the span of second day? They'll be calling you in the next function which we need to return the span. So for each day we need to return the span. So how can we find the span? So span is nothing but the maximum number of days, maximum number of consecutive days. This is an important point to be noted. Consecutive days in which where the price of previous days is less than or equal to price of current day. Today, let's call it as today. Less than or equal to, right? So price of previous days is less than or equal to current day. This is all about the definition of span. So yeah, so this is the definition of span. And so we'll have a test case to demonstrate the problem. So consider this test case. In this, the days are given. So initially will be called using a firstly will be called with 100. So firstly they will call the function next. So before that, they will be calling a constructor, that is stock spanner. So they will be calling this constructor call, and after that they will be calling the next parameter with 100. So when we get this call, we can initially the first approach that comes to everyone's mind is will be to create an array and store the days. So initially when we get 100, we'll be storing the 100 in an array. So we'll be storing 100 in a array, in a list, and we need to find the number of days less than or equal to the current price. So that is this span, right? So span for the current day will be 1 since there are no previous elements, previous days. So now we'll move to next day. So in this, next will be called with 80 as parameter, and 80 is the parameter of the current day. So we are in this current day. We need to check number of days. We need to find the stock of current day, which is having price of 80. So this is day 1, this is day 2. So current day's stock price will be 1 since there is only one day which the stock price is less than or equal to current day, which is the same day itself. So 100 is greater than current day, so we'll leave it. We don't consider this. So we'll move on to next, day 3. In day 3 the stock price is 60. So now we'll get 60 as the stock price, and we need to find the span. So the span count will be 1 plus, we'll move to left, it is 0, so it's all, and span will be 1. Next we are going to next day, which is day 4. Day 4 we have stock prices 70. So current stocks span will be 1, which is 70. When we move to left, it is 60. So 1 plus 1. So we might again go to left, which is 80. So 80 is greater than 70. So we ignore this. So finally our answer will be 2. So next we move on to next day, which is 60. So in day 5 there is 60. So in order to find the stock span, we'll move to left and check whether the element is less than or equal to current element or not. 70 is greater than 60, so we'll just ignore this and stop it. So the span will be 1, and we'll move to next, this is 75. For day 6 the stock price is 75. What is the span? So for finding the span, we'll move, for initially we'll have 1. Now we'll move to previous, which is 60. So 60 is less than 75, so we'll add it to 1, and we'll move to left. 70 is less than 75, so we'll add 1. Now again we'll move to left. 60 is less than 75, we'll add it to stock span. We'll move to left. We find that 80 is greater than 75, so we stop the iteration here, and we'll have the stock span as 4 since we add up to 4. So we'll move to next day, which is 85. So day 7 as 85. So for this we need to find this stock span. So what we need to do, so yeah, we'll do the same process. Initially we'll have stock span as 1, the current day. We'll move to left, it is less than 85, less than 85. 70 is less than 85, 60 is less than 85, 80 is less than 85. So when we count this, 1 2 3 4 5 6, so for current day stock span 6. So this is the final answer. So how can we build this? So let's move on to approach. So how can we find this answer? So the solution problem of this problem would be to have a list. So let's copy the test case. So let's consider this as an array, not as a function call. So we'll have this. So the second set is approach. How are we going to approach this? Our approach for this problem would be, first approach that comes to everyone's mind is to create a list and when each time during the constructor call, so let's call this as list, and it should be consisting of integer list, and we'll be storing when we get the function call as next with a price as parameter, we'll be adding to the list. Initially our list will be empty, right? So we'll add up to 100, and we'll find the span, that is for each time we'll move to left, as we have mentioned in the problem definition. In the approach, we have previously approached this problem, right? So in this way we'll be solving with the help of the list, and the time it takes for this approach will be O of n square, since for each element we'll iterate over each previous elements. So when we consider 85, we'll be going to previous elements, right? So the time complexity will be big of n square. Can we reduce this time complexity? The answer is yes. And how can we do it? It's so how can we do it? If we think about this logic, we can clearly see that we need to find the previous values, right? So in order to keep track of previous values, that is immediate previous values or previous values, we have to keep track of previous values. So how can we have the store the previous values? So we can clearly see that for consider this case. So initially we have 100, so 100 has only one as stock span. So we'll continue. So when we consider this number as 75, we can clearly see that the stock span will be 5, 4. So we can skip iterating over each element every time. So we'll see it how. Firstly, we'll have 100. Now we'll have 80. So 80 is less than less than previous value, right? So we'll have 80. So the stock span will store the corresponding stock span. So 1 and 1. Now we'll move to 60. 60 will be having stock span of 1. Since we'll check just the top value, previous value. So now we have 70. So we'll check the previous value. So the previous value is less than current value. So we can clearly see that we can add up to the stock, current span. So finally, we'll have 70 with stock span as 2. Now we'll move on to 60. So for 60, we can clearly see that previous is greater than current value. So it will have a stock span of 1, and we'll move to 75. For 75, we need to check the previous value. So previous value is less than 75. So we can add up to the stock price, which is 2, and we'll ignore this, and we'll check with the previous value, immediate previous value. Since we have removed 60, the immediate previous will be 70. So we'll check whether 70 is less than 75 or not. Yes, it is less than 70, and we'll add up the stock span of the 70. Why we are adding this? You can clearly see that the elements, that is the prices before these 70, which are 2, the stock span, all the days included in the stock span will be less than or equal to 70, right? So 70 itself is less than or equal to 75. So we can clearly see that the number of days which is uh, which is to be included for the stock of span of 75 will be adding 2 to it. So 70 along with 60. So this is stored as 2 here. So we'll be adding it to the current day. So after adding it, we'll remove this, and we'll check the previous immediate previous span. So it is less than, it is greater than current value. So we'll just stop the iteration and keep this as 75, and we have stock span as 4. So we'll move to next day. So we'll clear this out. 75 as 4. So 75 has 4. So we'll next day is 60. 60 is less than 75. So we'll check with previous value. It is greater. So we'll just have 1. We'll move on to 75. Sorry, we have concluded till 75, right? Now we'll move on to 85. So for 85, initially the span will be 1 and we'll move to left, and we can clearly see that span is, the current value is, previous day's value is less than 85. So we'll add the stocks, the span to current span, and we'll remove this and we'll check the previous value, that is previous day. So we can clearly see that 80 is less than 75. So we'll add up the stock price. Sorry, add up the span of previous day, which is 1, and we'll remove this and we'll check with the previous value. So for the previous immediate previous day, you can see that stock, the value is 70, which is greater than 85. So we'll stop the iteration and we'll return 6 as the answer. So that's all about this approach, guys. So the time complexity of the approach is, we have 1. We call this as amortized time complexity. So and the space complexity. So how can we keep track of previous alone? So in this we can clearly see that for each entry, it's called as entry 1 and entry 2. So for each day we are calculating previous, we just need previous days, right? So in order to get that, we can use a stack as a functionality of LIFO, last in first out. So whatever we have inserted in last, we can able to pop it out firstly. So we'll be using a stack, and the time space complexity will be big of here. So stack will be growing up to n number of calls. So this is it, and this is all about the time complexity and space complexity. Now let's get into the coding section. There we'll get the clear idea of how to use this, and the stack we are going to use here is called monotonic stack. Monotonic stack, and monotonic stack is nothing but the stack which has entries stored in ascending or descending order. So here we will be using ascending order. So you can clearly see that descending order. So from up to down. So descending order. Here we will be adding using descending order stack, monotonic stack. So that's all our approach. So you'll be very clear in the coding section. Let's move on to coding section. So initially we'll create a class, store the stock price. So we call this as stock, and have price and span as parameters. So initially we'll have a stack of stocks. We'll call this as previous stock, previous stock. So in the constructor is called, we'll be creating object of stack. So while each time we are calling the next function, we initially have span as 1, and while previous stock is not empty and previous stocks dot peak value, that is the this function call will enable us to get the immediate previous day stock. So if the immediate previous day stock's price is less than or equal to current day price, which is price, we'll add the span with previous stock's span. So finally we'll add up the current stock. So current stock, let's call this stock as current stock, stock as new stock of, we have a constructor which has two parameters, namely price and span. We'll assign the price and span to it. So we'll be passing parameters current price and span, and finally we'll push the current stock and return the span. So yeah, let's check this. It's working fine, so let's submit it up. Accepted. And approach for this problem is using monotonic stack. So actually I saw the solution in the discussion section. In this they have mentioned that actually the monotonic stacks problems can be really hard to wrap your head around initially, but it gets a lot easier with practice. So I have practiced several questions with using this concept, so I was able to come up with the solution easily. So initially it will be hard, but if you keep on trying, actually these type of problems will be very easy to solve in the futures. So that's all about this video, guys. Thanks for watching this. Have a great day.